Hello students, in this lecture we will see numerical number 5 using mesh analysis. The problem statement is find current supplied by the battery. This is the problem statement, okay, and there is only one battery. You can see here battery is power supply over here and that is 4 volt. So basically you have to calculate current supplied by this battery. Now in such cases the mesh analysis is the simplest method. So we have to solve this numerical using mesh analysis. So first step is identification of the meshes. So one can easily see here there is one mesh over here in this manner, and I am assuming that the current is flowing in clockwise manner and that is I1. The second mesh is over here and the current is I2. It is in again clockwise manner, and the third mesh, third current I3. Okay. So we have to obtain three equations by applying KVL in these three meshes. So I am writing KVL over here, KVL in mesh 1, okay. But before applying KVL, you have to assign the sign for the voltages developed across the resistance. So plus minus, and here you will have plus minus over here because I1 is flowing in this manner. So whenever current enters positive sign, when it leaves the resistance, you will have a negative sign. So I am writing the leaving sign of the voltages. I am starting at this point. So here you will have 4. Go ahead. Minus 3 times I1, go ahead, minus 1 time I1 minus I2. Don't forget I2 is also coming in this manner over here, and here you will have minus 4 times I1 minus I3, and you have completed the loop, so that is equal to 0. So we need to solve this thing. So 4 minus 3 I1 minus 1 time I1 plus 1 I2 minus 4 I1, and here I will have plus 4i3 is equal to 0. I will arrange the terms in the nice format, and that will lead to 8 times I1. I prefer the coefficient of I1 to be positive, and that is what I call it as a nice format. So 8 times I1 minus 1 time I2 minus 4 times I3 is equal to 4, and this is my equation number 1. Similarly, second equation you will get by applying KVL in mesh 2. Before applying KVL in mesh 2, you have to assign the sign for the voltages developed across the resistances. So I have mentioned the signs according to the direction of I2, plus minus, and plus minus over here. So I am starting at this point. So I will have minus 2 times I2, minus 5 times I2 minus I3, because I am moving towards left through 5 ohm, and the net leftward current is I2 minus I3. And over here I will have minus 1 time I2 minus I1, and I have completed the loop, that is equal to 0. So once you solve this thing, you will have minus 2I2 minus 5I2 plus 5I3 minus I2 plus I1 is equal to 0. So arranging the terms in nice format, what I will get, minus 1 time I1 plus 8 times I2 minus 5 times I3 is equal to 0. The right hand side 0 indicates that there is no voltage source, or the net voltage in this mesh is 0. Okay. Now the third equation you will get by applying KVL in mesh 3. So KVL in mesh 3. But before applying KVL in mesh 3, I will assign the sign for the voltages developed across the resistance. So plus minus, and plus minus has been assigned for the three resistances. Okay, the sign for. I am starting at this point, so I will have minus 6 times I3. 6 ohm is exclusively present in mesh 3. Go ahead, minus 4 times, and now you are moving upward in this manner. So here it will be I3 minus I1, and here you are moving towards right. So I will have minus 5 times I3 minus I2. And you have completed the loop, so it is equal to 0. So I will have minus 6 times I3 minus 4 times I3 plus 4I1 minus 5I3 plus 5I2 is equal to 0. Okay. Now arranging the terms in nice format, I will get minus 4 times I1. Then I will get minus 5 times I2. And here I will get plus 15 times I3. Actually I have transferred all these terms towards RHS, and that is equal to 0, and this is my equation number 3. So I have obtained 3 equations with 3 unknowns. I will just write down them in a matrix format over here. So in matrix format, this will lead to 8 minus 1 minus 4. Here I will have I1, I2, I3. Actually, writing the equation in matrix format, one can easily check just by looking at the circuit. So here I will have 4 over here. Okay, what this first equation for these values says, 8 is nothing but addition of all the resistances in mesh 1. 1 ohm is shared between mesh 1 and mesh 2. Current is flowing in opposite direction. That's why minus 1 over here. 4 ohm is shared between mesh 1 and mesh 3. Currents through 4 ohm are in opposite direction. I1 is moving downward, I3 is moving upward. That's why I'm a negative sign. And the net voltage over here is 4. So that is the indication over here. Similarly, I can have the second equation over here, and one can easily take the inference from those equations and their coefficients and constants. Okay. So this is in the format R into I is equal to V. So you can enter these coefficients and constants in calculator, and one can calculate I1, I2, I3. So I am writing I1 over here. So I1 turns out to be 0.658 ampere. You can check this thing. I2 is equal to 0.2426 ampere, and I3 turns out to be 0.256 ampere. But the problem is not over. They are saying find current supplied by the battery. So we'll write current supplied by the battery, and here the current supplied by the battery, which is of 4 volt, that is nothing but I1. So which is nothing but I1, and this is nothing but 0.658 ampere. Of course, the current will flow from higher potential to lower potential. So that is all about numerical 5. Actually, one can easily solve using finding the equivalent resistance across this one. But there are no series and parallel combinations of the resistances over here. So that process is quite complicated. So I have preferred mesh analysis over here. Thank you.